In today's class, we are going to learn about the Ohm's law. So, in 1827, a German physicist Georg Simon Ohm found out the relationship between the current I flowing through a metallic wire and the potential difference across its terminals. So, how did he find this relationship is by creating certain experiments. What he found out was as he was increasing the current, the potential differences was also increasing, and as he was decreasing the current, the potential difference was also decreasing. So, he concluded in his law that according to Ohm's law, the potential difference V across the ends of a given metallic wire is in an electric circuit is directly proportional to the current flowing through it. Provided its temperature remains constant. So this is our Ohm's law. So according to this law, what it is saying is that the potential difference V is directly proportional to I. So if I comes to the other side, we get V by I, and whenever we remove proportionality sign, we get a constant. And this constant we are naming over here as R. So V by I equals to R, or we get V equals to IR. This constant, we have written this as R. So, R is a constant for the given metallic wire at a given temperature. and is called resistance. This R, we name it as resistance. Now, what is resistance? To define it properly, when we define resistance, it is the obstruction offered to the flow of current by the conductor or wire is called its resistance. Okay, to understand this, let's look at this diagram. Say we take a cell. So in a cell we have two ends, a positive end and a negative end. So in the positive end, say we have connected a wire, and let's look at a magnified version of this wire. So a metallic wire, when magnified, is basically looks like a cylinder. So this is basically how the wire looks like when magnified. So a wire, when we consider, so this wire here is metallic in nature. So a metallic wire, we know that metals lose electron to form positively charged ions or cations. So this nucleus have positive charge and they are packed very tightly inside, because metals are solid in nature, and in solids what happens is the particles are very close to each other. So this metallic ions that are here, they cannot move. But what moves is the free electrons. We discussed about free electrons in the last lecture. Yeah, a metal has large number of wandering electrons and an equal number of fixed positive ions. These positive ions are fixed in nature. When a metal is formed, its atom loses electrons from its outer orbit. The positive ions do not move, while the electrons move almost freely inside the metal. These electrons are called free electrons. So the positive ions we have drawn, what is left is the free electrons. So these electrons are negatively charged. They will be attracted towards the positive charge. So electrons are attracted towards the positive charge. Positive charge means towards this charge. So these electrons, when they are attracted towards the positive terminal of the cell, what happens is on their way they get hit by this positive ions, the metallic nucleus. As they get hit, what happens is there is obstruction created because of this positive ions, and this obstruction that is created because of these cations that are present over here is called the resistance. Okay. So with increase in resistance, what happens is electrons will find it very difficult to pass through this one, because larger the number of positive ions, there is more obstruction over here. So electrons will not be able to cross this very easily. So with increase in resistance, current flowing through the material will decrease, and with decrease in resistance, the current flowing, or the electrons as they flow, the current is formed. So this current that will flow will also increase with decrease in resistance. Okay. You can also think of an example like this when say you are coming through a traffic jam. So say you have two paths. So the path you choose has a greater traffic jam, then what will happen is you will take more time to cross that. So just like this is like jam. So if there is more traffic jam, that is more resistance is there, your time taken will be much less, so the current will be very less. And if you are coming through a free road, what will happen is if it's quite free to travel. If it's easy to travel, there will be less resistance. It is like less resistance, and with less resistance there will be more electrons flowing through the path. As more electrons will flow through the path, there will be more current that will be present. So if resistance increases, current decreases, and with decrease in resistance, current increases. Okay, so the SI unit of resistance is ohm. Ohm is denoted by an omega. This sign is called an omega. This is denoted by omega. Okay, so what is the definition of ohm? The resistor of a conductor is said to be 1 ohm if 1 ampere current flows through it when a potential difference of 1 volt is applied across the ends of the conductor. Why we are taking 1 ohm is 1 ampere for 1 volt of potential difference is because we know V equals to IR. So from here we get R equals to V by I. So what we are doing is we are taking 1 ampere of current. If there is 1 ampere of current and 1 volt is there, so the resistance that will be formed will be equals to 1 ohm. So SI unit of resistance is ohm, and the formula for resistance we can say is equals to V by I. From V equals to IR we get R equals to V by I, and from this itself we can also write that I will be equals to V by R. So now if I equals to V by R, and if say potential difference is constant, I will be inversely proportional to resistance. Just like we discussed over here, if resistance is more, the current flowing through it will be less, inversely proportional, and if resistance is less, the current flowing through it will become more. So to note that, the current through a resistor is inversely proportional to its resistance. So if the resistance is doubled, the current gets halved, and so in many practical cases it is necessary to increase or decrease current in an electric circuit. So in order to regulate this amount of current flowing through an electric circuit, what we do is we regulate the amount of resistance in the circuit. So if we increase the resistance, what will happen is automatically current will decrease, and if we decrease the resistance, current will increase. So how can we decrease or increase the resistance? We saw something called a variable resistance or rheostat over here. So what variable resistance or rheostat does is that when we move this pointer to the left or right, so accordingly what happens is the resistance increases or decreases. So to increase or decrease the resistance, what we use is a rheostat. So a component used to regulate current without changing the voltage source is called variable resistance. In an electric circuit, a device called rheostat is often used to change the resistance in a circuit. Okay. So we know there are some appliances, like suppose if you use metals, what happens is metals allow good flow of current. Why does metal allow good flow of current? Is because it has very less resistance. And we know that wood do not allow flow of current. Why does wood not allow flow of current? Is because it has very high resistance. So one with very low resistance is called a conductor, and one with very less resistance is called a non-conductor or an insulator. So let's say this is note 1 and number 2. Substances which have large concentration of electrons. By electrons here we are referring to free electrons, offer less resistance, because if there are a large number of electrons, so more of electrons will be able to pass through the metallic wire or any wire. So as there is a large number of electrons, it will pass through the wire and current will flow. So substances which have a large concentration of electrons offer less resistance, therefore they are called good conductors of electricity. On the other hand, substances which have a negligible concentration of free electrons offer very high resistance, so they are called insulators of electricity. Okay, so before we learned, good conductors of electricity were those which allowed current to flow through it. Now we learn this definition in a new fashion, that substances which have large concentration of free electrons, is better we mention free electrons, offer less resistance, therefore they are called good conductors of electricity. And on the other hand, substances which have negligible concentration of free electrons offer very high resistance, so they are called insulators of electricity. Okay, so the next topic that we are going to deal are the factors on which the resistance of a conductor depends. Factors affecting the resistance of a conductor. So, without heading around the bush, we'll jump directly to the topic. So, first thing that it depends upon is the material of the conductor. So just like we discussed over here, that substances which have large number of free electrons will have less resistance, and substances which have less or negligible number of free electrons will offer very high resistance. So this is how nature or the material of a conductor affects the resistance in a conductor. You can say material, or we can also say this as or nature of the conductor. Different materials have different concentrations of free electrons, and therefore the resistance of a conductor depends on its material. Number 2, length of conductor resistance of a uniform metallic conductor is directly proportional to its length. Say L. So a resistance is directly proportional to L. Why does this happen is because the larger the wire will be, the more positive ions will come across. So the more positive ions we come across, the more the resistance will be there in the circuit. So with increasing length, the resistance increases because there will be more obstruction that will be created. So resistance is directly proportional to the length of the conductor. Third one is the area of cross section of the conductor. Conductor here basically means the wire. So resistance of a uniform metallic conductor is inversely proportional to the area of cross section. A. So R is inversely proportional to A. So let's say, okay, number fourth dependence is on the temperature of the conductor. Okay, for temperature of the conductor, let's again come back to this diagram. So think of this electrons. These electrons are moving with a certain velocity, so they have certain kinetic energy. So if you increase the temperature, what happens is heat energy is provided to the electrons. So with gaining heat energy, what happens is this heat energy converts this kinetic energy of electrons and it increases. So with increase in kinetic energy, what happens is this will move more randomly. So with increase in its movement, with increase in its speed, what happens is it will bump more and more positive this cations. So as it will bump more and more positive cations with increase in energy, what will happen is this resistance will increase. So with increasing temperature, what happens is there will be more bumps of the electrons into this positive cations. So with more and more obstruction that will be there, what happens is the resistance also increases. The resistance of a conductor increases with an increase in its temperature. Okay, so let's mark this as equation 1. Let's mark this as equation 2. So combining equation 1 and 2, what we get is R is proportional to L by A, or if we remove the proportionality sign, what we get is a constant, and this constant we denote by rho. And this alphabet is a Greek alphabet called RHO, rho, and this denotes resistivity. So R equals to rho L by A. So this is another important formula. Where rho is a constant or is a proportionality constant. Proportionality constant is a constant which comes after we remove the proportionality sign. So it's a proportionality constant and is called the electrical resistivity of the conductor. Okay, from here we get SI unit of resistivity is ohm meter. Okay. See, So resistance is equals to rho L by A. So if the resistivity will be very less for a material, what happens is the resistance is also very less. If the resistance is less, then it is a good conductor of electricity. So to note that substances, particularly metals and alloys, have a very low resistivity and are good conductors of electricity. And insulators have high resistivity. This is the first point. Second point is that resistance and resistivity of a material varies with temperature. The third point, alloys. This you may get as a give reason. Alloys do not oxidize, that is, it does not burn readily, even at high temperatures. So they are used in electrical heating devices like electric iron, toasters, etc. Fourth point, this question might come as why are alloys used in electrical heating devices? So we need to write that alloys do not oxidize readily at high temperatures. So they are used in electrical heating devices like electric iron, toasters, etc. And fourth point, tungsten is used for filaments of electric bulbs whereas copper and aluminium are generally used for electrical transmission lines. What happens is tungsten is used for electric bulbs because tungsten has high resistance, and as electric current passes through tungsten, what happens is it starts to glow. That is why tungsten is used for filaments of electric bulbs, and copper and aluminium, they have less resistance, hence they are used for electric transmission lines because they conduct electricity very nicely. Okay, with this we come to the end of today's lecture. We'll be discussing about some Ohm's graph and examples relating the formula for resistance that we have learned in the next lecture. Thank you.